Unit 4, pages 94 to 102, Solution Stoichiometry. In Chapter 3, we perform calculations using the stoichiometry of a reaction to convert from mass of a reactant to mass of a product. The diagram illustrates how to find the mass of product B produced from a certain mass of reactant A. To convert from moles of A to B requires a balanced chemical recipe or equation. Before the recipe can be used, the mass of A must be converted into moles. So here's just showing you have your balanced equation. You would change from grams of A to moles of A so that you could do a mole-to-mole ratio from A to B, and then you can convert B to grams. Calculation in solution is very similar except that concentration to mole relationships are involved using molarity and volume. Here's a diagram illustrating how to find the concentration of product B produced from a certain volume and concentration of reactant A. So you want to recall molarity times liters equals moles. So if you do molarity times liters, you get moles, and then you can do a mole-to-mole ratio. And then from there, you can take moles, and you have two options. Moles divided by liters turns into molarity, and moles divided by molarity is equal to liters, such as in this example specifically here. Example 4.34, magnesium oxide is a common antacid used to relieve stomach acid by neutralization. That's actually a key word that we'll talk about later. Let us imagine that stomach acid is hydrochloric acid and is present with this concentration. What volume of this acid can be neutralized by a 250 milligram tablet of magnesium oxide? So I've rewritten this equation below, and I've put that we have 0.15 molar and question mark volume underneath hydrochloric acid, and that we're given 250 milligrams of the tablet here. So what we want to do, it's a Stoich problem, so we're going to have to Stoich from magnesium oxide to hydrochloric acid, and in order to do that, we're going to need moles. So we want to take this 250 milligrams, and we want to convert it to moles. So I'll go milligrams to grams, milligrams, 1 gram, and then we're going to go from grams of magnesium oxide to 1 mole of magnesium oxide by using the molar mass from the periodic table, which is 40.31 grams. Now that I'm at moles, I can do a mole-to-mole ratio from magnesium oxide to hydrochloric acid, and that ratio is 1 mole of magnesium oxide to 2 moles of hydrochloric acid. And then here, I want to get my answer in moles. When I do this math, I'm going to get 0.0124 moles of hydrochloric acid. And now that I have the moles, I'm going to divide by the molarity that's given, because moles divided by molarity is going to equal liters. And when I divide these, I get 0.083 liters of hydrochloric acid. And so we wanted to get 2 moles so we could do the mole-to-mole ratio. And then once we had our answer in moles, then we can use one of our 3 equations, which would be molarity equals moles divided by liters. So I might have taken my moles and divided by liters and ended up with molarity. Or I take my moles and divide by molarity, and that gives me liters. So these are generally the 2 things that you'll do once you end up with an answer of moles after a Stoich problem. So titrations are a special solution reaction that's used to find out information about an unknown solution. Suppose you have a solution of base sodium hydroxide, but you don't know the concentration or its molarity. But you have a known concentration or molarity of the acid hydrochloric acid, which is added to neutralize the base. There's that word again, neutralize. So hydrochloric acid plus sodium hydroxide is going to yield water and sodium chloride. Everything's a 1-to-1 ratio. From the reaction stoichiometry, moles of acid added is going to be a 1-to-1 ratio between the acid and the base in order to determine moles of unknown base. The point where enough moles of acid have been added to react with all of the sodium hydroxide is called the equivalence point. Suppose the chemical equation was 2 acids to 1 base makes the neutralization, a 2-to-1 ratio. Then your equation would be this. The moles of acid added divided by 2 times 1 is going to equal the moles of the unknown base. Actually, there are no special formulas that are needed to solve these problems. The same solution equations you already know will work just fine. Example 4.35. You have 35 milliliters of unknown concentration, so that is unknown molarity, of a hydrobromic acid solution, and it's titrated with a 0.1 molar calcium hydroxide solution in which you have this volume. In order to reach the equivalence point, what is the unknown acid concentration? So first we have to write a balanced equation between hydrobromic acid and calcium hydroxide. You're going to write HBr plus calcium hydroxide, and remember all neutralizations are going to yield hydrogen hydroxide, which is water, just write water, plus calcium bromide is going to be our salt, plus 2 minus 1 switches to give us a subscript of 2 here. Now I'm going to balance it. Notice I have 2 hydroxides. So I want to have 2 hydrogens because 2 hydrogens plus 2 hydroxides is going to yield me 2 waters. And of course this also balances the 2 bromides from the other side of the equation, and we have 1 calcium. So now the equation is balanced. We have 35 milliliters of this hydrobromic acid, but we do not know the molarity, the concentration. We know that we have a 0.1 molar calcium hydroxide solution, and we have 73.7 milliliters worth. So this is a neutralization reaction, and you might remember the little trick way back when of multiply, Stoich, divide. And that's actually the process that we're going to use here and now. So I'm going to multiply these two because molarity times liters gives me moles, because I need this to be in moles in order to do the mole-to-mole ratio from calcium hydroxide to hydrobromic acid. So when I multiply 0.1 times 73.7, and I'm actually going to leave it in milliliters because it's going to work out, since I have milliliters here, we can just keep them both in milliliters. But you can change it to liters if you would prefer. So when I multiply these two, I get 7.37, and that's going to be moles, but because we kept the milli here, it's actually called millimoles, and this is of calcium hydroxide. Times, draw a line, and now I can do my mole-to-mole ratio between calcium hydroxide and hydrobromic acid. And we have a ratio of 1 to 2. So I have a 1 here, a 2 here, which means I'm going to multiply this value by 2, and that's going to give me 14.74, and that's going to be millimoles of hydrobromic acid. So now that I have this, I've done the multiply, I've done the Stoich here, and now what's left is to divide. I'm going to divide my millimoles of hydrobromic acid by the 35 milliliters of hydrobromic acid. Notice what happens. The millis cancel, and I'm left with moles per liter, which is the same thing as molarity of hydrobromic acid. And you should get 0.421. Mixtures of solutions now. Suppose we have a box that contains a volume of 1,000 liters of water. Into this box we put 1 bicycle and 2 tricycles. The bikes come apart in the water into frames and wheels. What is the concentration of wheels and frames in the box? To find the number of wheels, add the wheels from both sources. We have to consider the fact that the bicycles have 2 wheels per bike and the tricycles have 3 wheels per bike. To find the concentration, add up all the wheels and divide by the total volume. To do that, we calculate 1, 2, 3, 4, 5, 6 wheels that we get from the tricycles, 7, 8 wheels added to what we get from the bicycles. So we have 8 wheels for every 1,000 liters worth of water. And so this would be our concentration of the wheels. The calculation is slightly different for frames because each bike has only 1 frame. And so here I would add up 1, 2, 3 frames, and it would be 3 frames per every 1,000 liters of water total in order to determine the concentration of the frames. So now let's look at an actual mixture example problem. Suppose we have solution 1, which is 100 milliliters of a 0.15 molar sodium chloride solution, and it's going to be combined or added to solution 2, which is 250 milliliters of a 0.2 molar magnesium chloride solution. Using the analogy of the bicycles and the wheels, determine the molarity of the chloride ions, or the magnesium, or the sodium. So notice the concentration of chloride is going to be the total moles of chloride divided by the total volume. So this new volume is the total volume that we have to consider. Okay, so we're going to work this problem out on a piece of paper, and I'm going to talk you through step by step. So here I've written the two different solutions, sodium chloride, magnesium chloride. I have their molarities and I have the volumes that we were given for them. The first thing you're going to want to do is convert the milliliters to liters. So I've written that here. Number one, convert milliliters to liters. So this is going to be 0.1 liters and this is going to be 0.25 liters. Next, you want to multiply molarity times liters because that's going to give us moles, which is what we want to work in. So 0.15 times 0.1 is going to give me 0.015 moles of, this is important, label moles of what? Because when we break it into ions, we have to be considerate of how many ions we would produce once it dissolves. Then I'm going to multiply 0.2 times 0.025, and I'm going to get 0.05 moles of magnesium chloride. Now that I know the moles of both of my solutions, I need to determine the moles of the sodium ions, the moles of the chloride ions, the moles of the magnesium ions, and the moles of the chloride ions in the second solution. So when these dissolve, I'm going to get sodium and chloride, and here I'm going to get magnesium and chloride. So because there's only one sodium here, it's a 1-to-1 ratio between sodium chloride and the sodium ion, so it's going to be 0.015 moles of sodium. Again, 1-to-1 ratio between sodium chloride and chloride, so we're going to get 0.015 chloride ions from this solution. We have a 1-to-1 ratio between magnesium chloride and magnesium, so we're going to get 0.05 moles of magnesium. And then here, because of that 2, we're going to have 1 mole of magnesium chloride to 2 moles of chloride. So I'm going to have to take that concentration, the moles, and multiply times 2 because we have 2 chlorides here. And so this is going to actually give me 0.1 moles of chloride from this solution. Okay, now that we've figured out the moles of each ion, we're going to go to step 4, which is going to be using this equation. Total moles divided by total volume is going to give me the molarity. And it just depends on which ion you're going to choose. So let's go ahead and solve for chloride first. We have a chloride there and we have a chloride here. And so I'm going to put the total moles. So here we're going to solve for the molarity of chloride. Total moles is going to be 0.015 moles plus 0.1 moles, all of this is for chloride, divided by, and I've got to put the total volume down here. My total volume is these two volumes combined. So it's going to be 0.1 liters plus 0.25 liters. And when I do this math, I'm going to get 0.329, and that's the molarity of the chloride ions. So you can do this process for any of the ions that we figured out here. So maybe I want to know what is the concentration of sodium ions. Well, we only have sodium once here, and so I'm going to say question mark molarity sodium, and it's going to be the total moles, which is only 0.015 moles of sodium ions, divided by the total volume, which is the same as it was for chloride. And when you do this math here, you get 0.043 molar sodium ions. And then if we wanted to, we could go one more step and we could figure out the molarity of the magnesium. You could also be asked to find the molarity of the total ion concentration. And in that case, you would be adding up all 4 of these moles. So you would have 0.015 plus 0.015 plus 0.05 plus 0.1, because that's how many moles of total ions you have in this system. And then again, divide it by the total volume, 0.1 liters plus 0.25 liters. And when you do this math, you get 0.514 molar total ion concentration. Here's your note card for this section. So molarity times liters is going to give us moles. And so once we have moles, we can use stoichiometry, a mole-to-mole ratio, to change to moles of something else in a reaction. And then once I get that answer in moles, I could either divide by molarity, which would give me liters, or divide moles by liters, which would give me molarity. Generally, this is going to work, but it definitely works with titrations. When in doubt, you can multiply, that's multiply molarity times liters, stoich, that's stoich here, and then divide. In this case, we're dividing our answer by one other given. If you are not given molarity and liter, perhaps you're given something else that can be converted to moles first, and then you would continue on with this process. Or maybe you end up with moles here, and they don't want molarity or liters, maybe they just want grams, and then you just have to convert this answer to grams. All right, when in doubt, find moles, and then you can just about do everything for moles. When you have a mixture, then the molarity of the ions in the mixture is going to equal the total moles divided by the total volume. Be mindful when volumes are combined. It changes the concentration of the solution and the ions. And the total volume needs to be in liters. So also be careful about that.